Okay, these are your Chapter 9 story problems for linear relations, and we're doing the first two today. So the first question says the graph shows the simple interest for 1 year at 5% for different dollar amounts invested. And if you look at the graph here, we can see that we have the variable A representing our x-axis, which represents the amount of money they invest in dollars. So we see it goes up by $20 increments, $0, $20, $40. And then we see here a capital I, which represents the simple interest or the amount of money the bank will give you to let them hold on to your money. Right? That's called interest. So it says make a table of values for the data. So when we make your table of values, usually your first column is your x and your second column is your y. But since we're not dealing with x and y, we're going to make the first column your A, and we're up above it, we're going to put amount in dollars. And then we're going to have a capital I for interest in dollars. Okay? Then we're going to make our little sections here, and we're going to put the amount invested. The first one, I see, if you invest no money, you will receive no interest. That makes sense. If you invest $20 right here, you will receive $1 interest from the bank. They'll give you $1 after 1 year. If you keep $20 in the bank, they will give you $1 interest. So at the end of 1 year, you will now have $21 in the bank. If you invest $40, you will have $2 interest, and if you invest $60, you will have $3 interest. Okay? So then it says create an equation that represents this relationship. Well, we all know how to create equations because we've been doing it now for the last week and a half. We look for the difference in the y column, which is 1, and we look for the difference in the x column, which is 20. And the formula for your coefficient of your x and y, and I'm not putting x and y, I'm putting a and I, to find the coefficient for the relationship of the first part, you're going to have the difference in y divided by the difference in x, or the difference in y divided by the difference in x, which would be 1 over 20. Now if I use a calculator and go 1 divided by 20, I get 0.05. So there's 3 ways to represent that. You can say, oh, that's interesting. You can say 0.05 times a, or you can say 1/20th of a, or most importantly, since this is multiplication, you can go 1/20th times a, which would be a over 20. Okay? This way, and this way are all acceptable ways of showing 5% of the amount invested. Okay? This one makes the most sense because 5% is 5/100ths, and you want to get 5% of the amount invested, you would multiply it by 0.5. But what I'm going to do here is I'm going to keep, let's see if I can do this without destroying the place here. Oh, that's going to destroy it. Oh, heavens to Betsy. I'm going to keep my coefficient just like this. I'm not going to change it. I'm going to keep 0.05a. So then if I multiply, take my first ordered pair and substitute a for 0 and I for 0, I got to check to see if I need a constant. Are both sides equal right there? They are, which means I do not require a constant, which means my equation for my interest is 0.05 times the amount invested will be your interest, or a divided by 20 will equal your interest. Both of those are acceptable ways of representing the equation. And once you have that information, it says if the pattern continues, how much simple interest would $180 earn? Well, let's take either one of our, I'm going to take both of them just to show you that the same thing. Take both of our equations, which mean the same thing. If this is investing $180, that will be the amount you invest. So I'm going to substitute the amount I've invested, which is $180, to calculate the interest. If I take my calculator and multiply 0.05 or 5% of $180, I would find out that 9 will equal the interest. Okay? Same thing over here. If I substitute 180 for my A, 180 divided by 20 is still going to be 9. Right? So multiplying by 0.05 or dividing by 20 is the same outcome. Okay? Your second question says, Elena gathered data comparing the amount of time she spent studying for her tests and the marks she received. Make a table of values for this graph. So again, we're not going to use our x and y. Well, I can put x just kind of small here to remind you that that's x and that's y. But our x this time is going to be t, which is time, and in hours. And our y-axis is going to be s for test score, as a percentage. Okay? So then we're going to fill in our values. The first value I know is right here, which is 1 hour of time for studying. Her test score was 60%. For 2 hours of test studying, we have to kind of assume what this is. We can go right between here if we want. I'm not 100% sure, but it looks like 70. I'm going to leave it blank. I'm not going to do 2 because I'm guessing it's 70, but I'm not 100% sure. I know definitively what 3 is. 3 is 80. 4, again, I'm not 100% sure. I think it looks like 90, but I'm not sure. But I know that 5 definitively is 100. So the first 3 values I'm going to take are not 1, 2, 3. They're going to be 1, 3, 5 because I know exactly what the corresponding value in the ordered pair is. Then I'm going to look for my relationship between t and s. The difference here is 20. The difference here is 2. So to find my coefficient, I take the difference of the y column divided by the difference of the x column, and I get 10. Now 10 will be the coefficient in the relationship between t and s. Once I have that, I can take any of the ordered pairs, in this case 1 and 60. My t will be 1, my s will be 60. I will check to see if those two sides are equal. They're not. This side has a value of 10, this side has a value of 60. So I need a constant of 50 to make the two sides equal. And once I do that, I have the equation that matches all of the relationships of the points on this entire line. Okay? Now the question then says, does the graph appear to be linear? And linear simply means makes a straight line. It does appear to be linear, but if it was linear, it will go infinitely in both directions. Okay? For any value you give. The problem is there is a finite level here. So if I was to really draw the line for this, the line would look more like this. Because at that point there, when it shifts over, she can't, no matter how many hours of studying she does, she can't get up more than 100%. Right? So there is what we call like a plateau right here, where it's not going to be able to get 120%. Okay? So that's why she can't keep, it's not really linear. It's more, it's linear to a point, and then it changes over to a plateau. Okay?